This video is going to cover two exponent properties, the product and the quotient rule. Exponents are a way to show repeated multiplication, so let's take a look at two examples. I want to remind you first that when you're writing with an exponent, you have what's called the base and then the exponent. And the exponent tells you how many times to write the base using multiplication. So in this first example, I have 2 to the 5th power. So the 5 in the exponent position is going to tell me to write the 2 5 times being multiplied with each other. Same thing goes if I have a variable. The x is my base and the 3 is my exponent. So that 3 tells me to multiply my x by itself 3 times. Taking a look at the product rule. When you're using the product rule, you're going to have the same base and they're going to be multiplied together. So if you take a look at our first example, we have x to the 3rd times x to the 4th. Now what this means is if I were to expand it, I have x times x times x, that's x to the 3rd. And then if I take that x to the 4th, I have x times x times x times x. So the x to the 3rd told me to multiply x by itself 3 times. And the x to the 4th, that 4 told me to multiply x by itself 4 times. Now if I multiply them all together, my grand total is that I multiplied that x by itself 7 times. So I can rewrite that x to the 3rd times x to the 4th as x to the 7th power. Now when you're using the product rule, the reminder that I have for you is that you need to make sure that you keep the bases the same. So remember, in this example, the base was the x. And then all I needed to do was add my exponents. So I could have rewrote this example as saying x, there's my base, that's the same, and then 3 plus 4. That's how I could have had x to the 7th. Let's take a look at some examples. Using the product rule, I want you to take a look at this first example. 5x squared times x to the 5th. Now what I want you to know is that when I'm multiplying, I need to multiply the coefficients, or the numbers that are in front of my variable. So I'm going to do 5 times 1, which is going to be 5. But using the product rule, I can simply add my exponents. So I'm going to take that 2 plus 5, and that's going to become x to the 7th power. Let's take a look at the next example. Again, we're going to multiply our coefficients together. So I'm going to do 2 times 3, which will give me 6. And then I'm going to add my exponents together. Now, if you look at the second m, the one that's being multiplied by 3, there's not an exponent written. But we can assume that because I have one m, that's m to the 1st power. So I have m to the 4th times m to the 1st. So I'm going to add those exponents together to get m to the 5th power. Taking a look at the last example. Now I can use the product rule even with coefficients, with values. So if I have 3 squared, and I'm multiplying that by 3 to the 4th, that's going to be 3, so I'm keeping my base the same, adding the exponents, so it's going to be 3 to the 6th power, which is equal to 729. Now let's take a look at the quotient rule. Now the quotient rule, again, is making sure that we have the same base, but this time we're going to be using either a division symbol or it's written out as a fraction. And you can see that with both of my examples. I have used the division symbol in the first example and then the fraction on the right. If I were to expand this to show you how the quotient rule works, if I expand that p to the 8th power, that means I'm going to be multiplying p by itself 8 times. And if I expand p to the 3rd, that means I'm going to be multiplying that p by itself 3 times. Now, when you are using division, you want to look for giant ones. And I see 3 of them. P divided by P is a giant 1. P divided by P is another giant 1. And I have another 1 right here with P divided by P. Now, what that does is it leaves me with 5 P's being multiplied together. So that's going to be P to the 5th power. Now, an easy way to do this is, as if we take a look at the reminder, is keeping the bases the same, which we did in our expansion. We kept the P's the same, but then we subtract the exponents. So one way we could either do this is top minus the bottom, and if you looked at my expansion problem in orange, I could have done 8 minus 3 to get P to the 5th power. Or we can do left minus the right if your example or if your problem is written like this one with my Q's at the very top. Let's take a look at some quotient examples. So if we take a look at this first one, m to the 6th divided by m. Now this is where I want to use the subtraction left minus the right. And remember that this second m has an exponent of 1. So really what I'm doing is keeping my base the same, so m, and then doing 6 minus 1, which will give me m to the 5th power. Over here, this second example, I'm doing the top minus the bottom. So I'm going to do, keeping my base the same, but then I'm going to do 3 minus 6, which is going to be x to the negative 3 power. Now this last one has some coefficients in it. It has some numbers in front. Now when you have that, you want to divide those values. So I'm really going to do 4 divided by 2. So that's going to be 2. And then I'm going to subtract the exponents that belong with my base of y. So here I have y as my base, but I'm going to do 5 minus 2. So really my answer is going to be 2 because I did 4 divided by 2, and then the subtraction, so y to the 3rd.